Section 6.4, Rational Equations. A rational equation is an equation that contains one or more rational expressions. Recall, we can clear fractions from an equation by multiplying both sides of the equation by the least common multiple of the denominators. Most of the rational equations that we will encounter contain a variable in at least one denominator. Since division by zero is undefined, and a replacement for the variable that makes a denominator zero cannot be a solution of the equation. We can rule out these numbers before we even attempt to find a solution. After we have solved the equation, we must check that no possible solution makes a denominator zero. So let's get started. Yuck! There's fractions here. So to eliminate the fractions in this equation, we will multiply by the least common multiple of the denominators, and between 5 and 3, our least common multiple, the smallest number that both of those would go into, is the product of 5 and 3, in other words 15. So every term will get multiplied by 15 to maintain equality. The 15 will cancel out the 5 in the denominator, leaving a 3. 3 times 2 times y leaves us with a 6y. The 3 will cancel out the 15 and leave a 5. So 5 times y is 5y, and 15 times 5 is 75. Rational equation gone. We have an equation. Simplifying for solution, 6y minus 5y is 1y is equal to 75. There were no variables in the denominator. We don't need to concern ourselves with restricting the denominator or the solutions to avoid having a division by zero error. Not the case in this next example. Values that x cannot be are clearly 0. If x was a 0, we would have a division by 0 error. So x can't be 0. That's the first thing we want to make sure. Next, we'll want to clear the fractions by multiplying every term by the least common multiple of the denominators. So that least common multiple here is x, since both denominators are x. To maintain equality, we'll multiply every term by x. The x over 1 cancels out in this first rational expression, leaving a 15 times 1 or 15. 4 times x is 4x, and the x over 1 on our last term here cancels out the x in the numerator and denominator, leaving a 1. 1 times 1 is 1, so we have a 4x minus 1 on the right. The rational equation is gone. We're left with an equation to solve. We will add a 1 to both sides, giving us 16 is equal to 4x. Divide both sides by 4, and x is equal to 16 divided by 4, or 4. That is not part of our restriction on our variable. So other than checking to make sure that it works, everything looks good for the solution to this problem. In this next rational equation, to simplify this, we will want to get rid of the fractions, but first we want to be sure we state what values of x the denominator cannot take on so that it results in a 0. And here we have a complicated denominator. If we factor this, factors of 18 that add up to be 9, both signs the same, both positive, turns out to be an x plus 3 times x plus 6. So we do not want our x to be a value that will turn this into a 0. That would mean x cannot be a negative 3, because that would give us a 0 here, nor can x be a negative 6. When we set this equal to 0 and solve for x, we would end up with a negative 6 plus 6 would give us a 0. That's a bad thing. And this third rational expression in this equation has those same denominators, so anytime an x would be a negative 3 or a negative 6 would result in the denominator being 0 and undefined, something to avoid. Next, to simplify this, we'll multiply by the least common multiple of the denominators, which is x plus 3 times x plus 6. So each one of these three rational expressions will get multiplied by the least common multiple, which is the product of these two. So our first term gets multiplied by x plus 3 and x plus 6. Our second term gets multiplied by that least common multiple, so 1 over x plus 6 minus, again, we'll take our x plus 3 times x plus 6 and times it by our last term here, which is 6 over, and I'm going to replace that trinomial with the factored equivalent expression for that. So, simplifying, these have denominators of 1. We have an x plus 3 common factor to an x plus 3 in the denominator, leaving us with a minus 2 times x plus 6. We'll come back and simplify that. Is equal to, again, these have a denominator of 1. We're multiplying fractions together. The x plus 6 over the x plus 6 cancel out, leaving a 1 times x plus 3, which is just x plus 3. And here on our last multiplication, the x plus 3 cancels out, leaving 1, and the binomial x plus 6 cancels out the x plus 6, leaving 1. 1 times 6, and we have a minus there, is a minus 6. Simplifying further, our rational equation is gone. We're simplifying the equation, starting with distributive here on the left, 2 times x. A negative times a positive leaves us with a negative 2x. Negative 2 times positive 6 is a negative 12. The 1 times this quantity is just that quantity, and we still have our minus 6. Simplifying this further, we can simplify on the right. Plus 3 minus 6 is a minus 3. Getting our variables together, doesn't matter which side. If we want to avoid a negative exponent, we can add 2x to both sides. Since the variable will be on this side, let's add 3 to both sides at the same time. Maintaining equality, doing the same thing to both sides. The x's are gone. A negative 12 plus 3 is a negative 9. 1x plus 2 more makes 3 x's, and the 3's cancel out. Last, to solve for our variable, 3 divided by 3 leaves us with 1x, and negative 9 divided by 3 leaves us with a negative 3. So it appears the solution is x equals negative 3, but that may remind you a little bit of what values did we restrict our domain? Oh yes, there it is. X cannot be a negative 3 because that would give us a 0 in the denominator. That was the only solution this equation had. So we have to reject it because of the fact of where that variable is placed in the denominator if it takes on the value of negative 3. This is undefined, and therefore it's telling us that there is no solution to this rational equation. Let's look at one more rational equation. Again, we want to be sure we identify values that will cause this to be undefined. If x or y is equal to a negative 5, we would end up with a 0 in the denominator, so we don't want that to be the case. Furthermore, if y was a 5, 5 minus 5 would give us a 0. So we do not want y to take on the value of positive or negative 5. This denominator is a difference of squares. It factors into y minus 5 times y plus 5, which we've already identified what values would cause this to equal a 0 and give us an undefined expression. So we've got our values that the variable cannot be. Next, to eliminate this rational equation, we'll multiply by the least common multiple of the denominators, which will have to have a y plus 5 and a y minus 5, which is here combined. So our least common multiple will be x minus 5 and an x plus 5. So to maintain equality, every one of the three terms will be multiplied by, and I'm saying x, and it should be a y, I'll write it here, y plus 5 times y minus 5 times the first term. Again, maintaining equality, y plus 5 times y minus 5 times the second term, 5 over y minus 5, is equal to, and we do it again to maintain equality. We've multiplied the first two terms. That third term also needs to be multiplied by the same quantity to maintain the equality. And I will write it in its factored form so we are sure to see that it does in fact cancel out. So these binomials are understood to have a denominator of 1. The y plus 5 over y plus 5 cancels out, leaving the binomial times 3. In other words, 3 times the y minus 5. In the second term, the y minus 5 over y minus 5 cancel out, leaving a 1. And we have a binomial times this 5 with a minus, so I'll put the 5 in front and the binomial next. And on the right-hand side, these two binomials, which are over 1, when we're multiplying rational expressions, we multiply numerators, multiply denominators, and cancel out common terms. They cancel out our denominator, leaving a 1 times 6, or 6. Rational equation is gone. Our goal now is to simplify and solve for the variable. Distributively, we end up with a 3y minus 15 for the first expression. A negative 5 times y is negative 5y. A negative 5 times 5 distributively gives us a negative 25. Is all equal to 6. Simplifying on the left by combining like terms, 3y minus 5y leaves us with a negative 2y. A negative 15 plus a negative 25 leaves us with a negative 40 is equal to 6. Solving for the variable, we'll add a 40 to both sides, leaving a negative 2y is equal to 46, and divide both sides by negative 2. Will leave us with a positive y. Positive divided by a negative is negative, and 46 divided by 2 is negative 23. Is that an okay value? Well, we'd have to plug it in to check, but before we do that, is it part of our restricted domain? Y can't be a positive or negative 5. We're good on that count, and other than some arithmetic error which would be caught by checking, it appears that y equals negative 23 is a solution.